Hi everyone. Today I am going to discuss about motion in a straight line chapter. Before that, those who are watching my videos first time, do subscribe my channel and like the videos and do share the videos with your friends. Dear students, today I am going to discuss about motion in a straight line. You all know about the what is meant by motion. Okay. Motion means when a body or particle will starts moving from rest position to some other position with respect to time interval is known as motion. During motion of a body, we are observing many physical quantities which are related to motion of a body. Those are known as distance, displacement, speed, velocity, force, momentum. Like that, we are observing the so many physical quantities during a motion of a body or particle or object. Here, the motion is classified into three type of motions. Okay, those are one dimensional motion. This is 1D, and this is 2D, and this is 3D. Okay, in all type of motions, the physical quantity remains same. Only difference is measuring axis. First of all, come to the one dimensional motion. Here, this is the one dimensional motion. Here, straight line is there. O is the origin point or reference point from which we are measuring the motion of a body. Here only single axis is there, that is x axis. Okay, by using this single axis we can easily measure the physical quantities. Okay, for example, motion of a particle in a straight line. A car is moving in a straight line, an object is moving in a straight line. These are the example for one dimensional motion. And come to the next one, second type of motion, that is two dimensional motion. Two dimensional motion. Here the two measuring axes are required. Those are, here I taken x axis and y axis, and O is the origin position. From this point O we are calculating the magnitudes of motion during a two dimension. Next, this is a three dimensional diagram. Here we are using three axes, x, y and z axis. The motion of a body is measured using three axes, is known as three dimensional motion. For this example we will discuss in below. First we will see the definitions. Okay, one dimensional motion. Here definition, motion of a body is measured using single axis, is known as one dimensional motion. Example, a car is moving in a straight path, a particle moving in a straight line, an object moving in a straight path. Okay, next, second type of motion, two dimensional motion. Here, motion of a body is measured using two axis, is known as two dimensional motion. Any axis you may take x y combination, y z axis or z x axis. There must be a two axis for measuring the physical quantities. For example, throwing a ball to another person in a curved path. When a person throws a cricket ball to another person, that must the ball must be travel in a curved path, circular path. Then only it is calling as a projectile path or two dimensional example. Next one example, projectile motion of a body. Just only I told you may throw ball or any object in a curved path. Hmm. That is the example for two-dimensional motion. Okay. Next, next I will discuss about three-dimensional motion. Motion of a body is measured using three axes. Okay, is known as three-dimensional motion. For example, a bird flying in the sky, an aeroplane moving in the sky, a kite is moving in the sky. Means the body or object must be travel in a space that too freely. Okay, such type of examples are three-dimensional motion. Okay, next one. Here in this chapter, motion in a straight line. This chapter belongs to one-dimensional motion. Here we are measuring the physical quantity using only single axis. Okay, before going to the concepts, we have to know about the some basic terms. Those are known as distance. When a body start moving from one place to another place, we are observing the distance. Here distance means the total path length covered by an object. Total path length covered by an object. For example, here the position A is there and position B is there. Okay, the object must be travel from A to B. Here the object A may travel in any possible directions. It may travel in a straight path, or it may travel in a curved path or zigzag path. Okay, there are three paths are there to reach from A to B. The total path length covered by an object is known as distance. Okay, the body or particle may travel in any possible direction. This is a scalar quantity. Distance is a scalar. Why? Because there is no direction. That's why it is a scalar quantity. Okay. Next, come to the displacement. Change in the position of an object is known as displacement. Here, a body or particle must be travel from position A to B. Here, I am mentioning the direction to this path. The body or object must travel now on this path only, particularly. Why? Because I shown the direction here. That's why it's become a vector quantity. Displacement. Change the positions. Position A, position B. Initial position is A, final position is B. Okay. Change the position of an object is a vector quantity. Next one, velocity. Okay. When a body is moving from one place to another place, we can easily calculate the velocity. Velocity means the rate of change of displacement with respect to time. It is a vector quantity and SI unit is meter per second. Here, taking the formula velocity. Displacement by time. Okay, displacement by time is known as velocity. Here, displacement may be written as x2 minus x1, means change in the positions divided by change in the time interval delta t ಅಂತ ತಗೋಬಹುದು ನಾವು t2 minus t1. Okay, that becomes delta x displacement interval and time interval delta t. Okay, now coming to the SI units. Okay, here displacement is measured in meter and time is measured in second. Okay, changing the second to the numerator, that becomes meter per second. Okay, meter per second is the SI unit of velocity. Next, in the same way, here in velocity we can also measure the different type of velocity. Those are known as instantaneous velocity. The it means velocity of a body at particular instant of time. Means we are calculating the velocity of a body for 2 seconds. Okay, for 2 seconds the body having certain velocity, and for 4 seconds again the body having different velocity. Like that we are calculating the velocity with respect to instant of times. Okay, such type of velocity is known as instantaneous velocity. Next we are discussing about average velocity. Average velocity, here we are observing the, suppose, 5 instantaneous velocity. There are 5 velocity magnitudes are there. We are summing those all 5 velocity magnitudes and divided by 5. We are doing that. Okay, we are taking the average of all those velocity. Whatever the value we got at final, that is the average velocity of a body. Okay, like that we can easily calculate the instantaneous velocity and average velocity. In the same way, next one we will discuss about speed. Speed is also a physical quantity. Okay, here the speed definition is the total distance traveled by body with respect to time interval. The formula is total distance or total path length divided by total time. Okay, here distance also measured in meter and time measured in second. Okay, the SI unit is meter per second is the SI unit of speed. Both are having the same velocity. Both are having the same SI units. Okay, the speed as well as velocity. Unit is meter per second. Next, here the speed is a scalar quantity. Why? Because it has only magnitude. There is no mentioned direction to a speed of a body. It is a scalar quantity. For example, in a government bus, we are observing that the speed limit is 60 km per hour. Okay, the bus may travel in any possible direction with a 60 km per hour. There is no direction is mentioned. If we mention the direction to a bus, the bus must be travel in a particular direction. Then that magnitude is called as a velocity of the bus. Here we are differentiating the quantity, speed as well as velocity. If direction is mentioned to a body or bus, here it becomes vector quantity. Then the magnitude becomes vector quantity. Okay. Here also we are discussing about instantaneous speed and average speed. Speed of a body at a particular instant of time is known as instantaneous speed. 2 second, for 2 second the body how much speed it is occupied, and for another speed how much the body occupied. Okay, for example, first for first 2 second the body may have 60 km per hour speed, and another 2 second it may have 40 meter per second. Okay, in such a way we are having the different magnitude of speeds. We are making the average. Okay, that average magnitude is known as average speed of a bus or vehicle. Okay. Okay, remaining concepts I will discuss in next class. Thank you.